Hello students. Today we are going to learn about the new topic, okay, and that is prime factorization. Okay, in the last class we studied about the prime numbers and the composite numbers, right? Now here we are going to learn about the prime factorization. Okay, how will you do the prime factorization? Okay, there will be some numbers suppose I give you 36. Okay, suppose you have to prime factorize this, means you have to find the prime factorization of 36. Okay, so how will you find this? Okay, as the name itself indicates that we are going to do with prime numbers, because in the name we have prime factorization. Okay, so composite numbers we are not going to use, we are only going to use prime numbers. Okay, so first you have to see, so while doing prime factorization, okay, so I will write like this. First you have to check from start from 2, because 2 is the smallest prime number, and then 3. Then we'll not do with 4 because it is a composite number. We'll do with 5, then with 7, then with 11, then 13, then 17, then 19, and so on. Okay, so in that fashion we will see with each prime numbers. Okay, first, as I already mentioned, we'll start with 2. So you have to see whether this number is divisible by 2 or not. So is it divisible by 2? Yes, it is. It is 2 how many times? 18. So did you get my point? First, if it is divisible by 2, then you have to divide by 2. So 2 how many times? 18 times, right? So next, again you have to check this one. Now is it divisible by 2 again? Yes. So again you have to divide by 2. 2 9, right? So now we got 9. So now again you have to check whether this will be divisible by 2 or not. So is it divisible by 2? No, 9 is not divisible by 2. Then you have to move to 3. You cannot directly move to 5. Okay, you have to check with 3 first. So 3. Is it divisible by 3? Yes, it is, right? Because 3 is a 9, isn't it? So the last one 3. So obviously it is divisible by 3. Okay, so 3 1. Okay, so you have to do till where you get 1. So after you get 1, you have to stop. Okay, stop. Okay, so what is the prime factorization of 36? So 36 equals to, so you have to see this one. Okay, so it will be 2 into, this is into 2 into 2 into, after that 3 into, so 2 into 2 into 3 into 3. Okay, so you can check also, because 2 2s are 4, 4 3s are 12, 12 3s are 36. So the prime factorization of 36 is 2 into 2 into 3 into 3. So as the name is prime factorization, there cannot be any composite number here. Okay, see, all the numbers are prime. 2 is prime, 2 is prime, 3 is prime, 3 is prime, isn't it? Similarly, if I give you another number, okay, so that is, suppose if I give you 175. Okay, so if I ask you to see whether ask you to find the prime factorization of 175. Okay, so first what will you do? You will see whether it is divisible by 2 or not. So if you see it is not divisible by 2. Okay, so next, is it divisible by 3? So if you see it is not divisible by 3 also. Okay, so it will be divisible by 5, isn't it? So 5. So 5 how many times? 5 how many times is 175? We are not checking with 4 because 4 is not a prime number. Okay, so that is why I am directly going to 5. So 5 how many times? 5 3 is a 15. Okay, and 2 is, remember, 5 5 is a 25. So 5 35 times. So next again with 5, I guess, because it is again divisible by 5. 5 7 is a 35. No, this one with 7. 7 ones are 7. So 175 will be equal to how many? 5 into 5 into 7. So it will be 5 into 5 into 7. Okay, so this is how you will do the prime factorization. Okay, so in this way I want you to do exercise 3C. Okay, exercise 3C, it is page number 66. Number 1, okay, write true or false, that is using the previous concept, okay, about prime numbers and the composite numbers. Then 2, okay, which of the following are prime numbers? So out of these numbers you have to select the prime numbers. Okay, and number 3 is which of the following are composite numbers? Out of these you have to select the composite numbers. Obviously those which are not prime, they are composite. Then you have to find the prime factorization, which we did just now. Okay, so in similar way you have to prime factorize all this. Okay, so this I want you to do it as a homework. Okay, so in the next class I will teach you how to find the HCF using this prime factorization method. Okay, so till then you practice this one, especially this one, the prime factorization of the numbers. Okay, because this we are going to use to find HCF and LCM. Okay, and we'll proceed in using this process. Okay, so that is why I want you to practice this at home very nicely. Okay, and again I am telling you, you have to first start with the smallest number, that is 2, 3, 5, and then if not with 5 then with 7, if not with 7 then only with 11. Please don't skip. Okay, you cannot directly do with 17. Okay, you cannot directly go to 5 without checking for 2 and 3. Okay, please go step by step. Okay, and don't use the composite number. You cannot use the composite number while prime factorizing. Okay, because the process itself says prime. It means you have to use prime numbers only. Okay, so prime number means what? You have to first check with 2, then with 3. If not with 3, then with 5. If it will not go with 5 also, then with 7, then 11, then 13, then 17, then 19. If not with 19, then you have to go for 23, then 29, then 31, and so on. Okay, so there are infinitely prime numbers. Okay, but you have to check from the smallest one. If not with 2, then with 3, 5, and so on. Okay, so keep it in your mind. Please don't skip. Okay, and don't use the composite numbers. For example, if I say, if I am prime factorizing for 8, okay, I cannot do with 4. No, 4 2 is 8. No, this is wrong. Okay, this one will be wrong. You have to do with 2 because 2 is a prime number. Okay, so this is very, very important point. Keep it in your mind. Okay, so I'll meet you in your next class. Okay, and I'll teach you how to find HCF by prime factorization.